Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And you have found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
In our last episode, we started answering a question from a follower of our Math is Figureoutable teacher Facebook group. And so today we've decided we're going to continue to answer Beth's question. And Pam, I wanted to tell you that this is also timely because not too long ago, I got a text from a good friend of mine that you know well. And she said, "Hey, Kim, here's a problem that my kid has to solve. How can I think about this?" And I loved her question because it wasn't, "What's the answer?" Like, just tell me what to tell my kid. She was interested in thinking. So I think there are probably plenty of people out there who want to learn how to think about division of fractions.
Absolutely. And so Beth Roberts, thanks for asking the question about how to teach division of fractions. So we started last time, we did some whole number divided by fraction. We also did some mixed number divided by fraction. Let's dive in more to some reasoning that we would want to develop about fraction division. Last week, we did some problems like 3 1/3 divided by 1/3. And we thought about how many unit fractions are in a bigger number. Mm-hmm. So all of the problems last week had dividends, or the sort of first number in the division problem, that were bigger than the divisor, like 3 1/3 divided by 1/3. So 3 1/3 is bigger, the divisor is 1/3. How many 1/3s can we get out of 3 1/3? That's a very quotative approach to thinking about division. In a way, what we did last time was really focus on the definition of a unit fraction. What's a unit fraction? It's when the numerator is 1. So it's like my fair share when I'm thinking about sharing. So if I'm sharing a candy bar and I'm going to share it with 4 other people, so 5 of us are sharing, and I share it fairly, then what do I call my piece? I call my piece 1/5 because 5 people are sharing. Well, what if 7 people were sharing? Then I call it 1/7. The definition of a unit fraction is sort of one person's fair share if you share the thing fairly with that many people. That's important. We need to know what 1/12 looks like, 1/8 looks like, 1/2 looks like. We need kids to reason about the relationships between that unit fraction and a whole, the unit that we're sort of cutting up and dividing fairly. Yeah?
Yep.
So today we're going to continue to take a quotative approach. How many of the divisors are in the dividend? So, for example, if I was dividing a whole number problem like 210 divided by 10, that's asking, if I'm looking at it quotatively, that's asking the question, how many tens are in 210? So if I was going to reason about how many tens are in 210, I might reason about how many tens are in 100, because I know that. And then I could double that to think about how many tens are in 200. And I could just tack on that extra one more 10 in 210. So that would be a way of me sort of reasoning about the number of tens in 210. I wonder if we could use similar reasoning that we just did with whole numbers. Could we use similar reasoning to think about division of fractions? So here we go. All right, Kim. If I had a candy bar and I'm going to split it up and share it, and I'm thinking about sharing it with 4 other people, so 5 people are sharing, what is 1 candy bar divided by 1/5? How many 1/5s can I get out of 1 candy bar?
well, you're gonna have 5 because you just told me that. How many people you have? So 1/5. There are 5 1/5s in one.
Did I do too much there? too much of your own thinking. So I want to start in a place where kind of everybody can access again.
Yep.
We're kind of reminding ourselves what we did last time. And so
Yep.
you're saying that that the answer to 1 divided by 1/5 is 5 because there's 5 1/5s in 1. So
Yep.
I've quickly sketched a candy bar. I've sort of eyeballed dividing it into 5 equal pieces. I've kind of dotted those. I put some dotted lines so we can see 5 chunks of that rectangle. And I've labeled the first chunk, I've labeled it 1/5. So a little bit less labeling than I did in the problem string that we talked about in the last episode. Okay, next problem. I've only got half a candy bar, Kim. So what is 1/2 divided by 1/5? And what does that mean with our candy bar scenario?
So when you had a whole candy bar, 1 divided by 1/5, then you had 5 people or 5 pieces. But now you have only half as much candy bar. So you're going to have half as much people or per person. Let me think about I can't remember exactly what your scenario was. 1/2 divided by 1/5 is 2.5. Because in the previous problem, you said 1 divided by 1/5, and now we have half divided by 1/5. So the answer is going to be half as much.
Since the answer to the first problem is 5, the answer to
Yeah.
the next problem is going to be half as much, which is 2.5. Half of 5
Yeah.
is 2.5. Yeah.
Yeah.
So you were like, what was the scenario again? So that's a good question. Like I said, I have a whole candy bar, and I want to share it with 5 people, so they each get. Well, I guess what I should say is I've got a whole candy bar, and I've cut it into 5 equal
There you
sections.
go. Yeah.
I've cut it into
you
5
cut it
equal
into
sections.
fifths. How
Cut it
many
into
people?
fifths. How many people can I give a fifth of a candy bar to?
I think that's why I was like, wait a second, because in this scenario, it would be 2.5 people.
Yeah. So that's kind of weird, right? How many
Yeah.
fifths can I get out of half a candy bar? Well, I can
2.5
only get 2.
fifths. Yeah.
I can only get 2.5 of those fifths.
Yep.
So that's not so great, right? For 2.5 people. So that's kind of weird to think about. But I can think about, I can only give that same amount to half as many people.
Yes.
Cool.
Yeah.
Okay. So what if I had a problem like, I'm back to a whole candy bar, but this time I'm going to split it into tenths.
Okay.
How many tenths can I get out of that candy bar?
10. 1 divided by 1/10, because there's 10 tenths in a whole.
10 tenths in a whole. So 1 divided by 1/10 is 10. How does that relate to the problem 1 divided by 1/5?
Oh, good question. I hadn't thought about that. I
like it when I get Kim to think. Bam! That's a good day.
Let me think if I can say this right. I still have 1 candy bar, but instead of fifths, now the size of the piece is half as big, right? So instead of fifths, now I have tenths. The size of the piece is half as big. So I'm going to have twice as many of those pieces.
Right? Yeah.
Yeah.
Because before I had 5 1/5s, but I've cut now I have tenths, and tenths are half as big as fifths. That's like the definition of a tenth, right?
Yep.
In fact, often if we say to kids, hey, draw a rectangle and cut it into tenths, some of them will cut it into fifths, and then they'll cut each of those fifths in half.
Yep.
And then they've got tenths. Cool. So you're saying that if there's 5 fifths in 1 divided by a fifth is 5, then there's 10 tenths in 1 because you've cut the pieces in half, so there's twice as many. Nice. What if, so on my candy bar, I went ahead and cut the candy bar into fifths again. So I've kind of underneath the one I had before, I've cut it into fifths, and then I've cut each of those. Actually, I've only cut the first one in half, to be honest with you. And I've labeled that piece as 1/10, and I've labeled the second 1/10 as 1/10. So I have two little pieces labeled as 1/10, and I kind of have an overarching one of those brackety things above the two 1/10s, and I've labeled that as 1/5. Does that make sense? So I kind of have a 1/5 labeled. I've cut it in half, and I've labeled each of those halves as 1/10. All right, cool. Next problem. How about if I ask you for 3/5 divided by 1/5?
3.
Well,
3/1/5 and 3.
There's 3 1/5 and 3 is your answer. It's your final answer.
Yep.
Cool. So I might draw that whole candy bar, and I might divide it into fifths, and then I might circle 3/5, 3 of those 1/5s. And then I might say, so that's what you're focused on is those 3 1/5s? Because you just were like, bam, 3. And in those 3 1/5s, you can see 3 1/5s. So it's interesting because I actually want to call, so the problem 3/5 divided by 1/5, I actually want to say 3 1/5 divided by 1/5. How many 1/5s are in 3 1/5? And I think you said that. How many 1/5s are in 3 1/5? There's 3 of them. So listeners, you might recognize that I'm calling the non-unit fraction 3/5. I'm actually naming it 3/5, but I'm also naming it 3 1/5. Not 3 and 1/5, but 3 1/5. And I'm simply writing the fraction 3 fraction bar 5, but it can have two names, and one of the names is 3/5 and one of the names is 3 1/5. And we find that helpful. We find it helpful to talk about these non-unit fractions in terms of their unit fractions. That can be helpful in some cases. All right, cool. How about the next problem? The next problem is 3/5 divided by 1/10.
You want to know what I really thought?
Can I ask? Yes, I want to know what you really thought about, and then I'm going to ask you a question. Go ahead. What do you really think?
So what I really thought, I know that we're living in the land of fractions, and I see a relationship between.
Oh no! I know where you went.
Previous problem, but I really thought 60 cents divided by 10 cents.
Like, because you're just this percent girl. You were.
I mean, either percents or dimes or whatever, like all of it. Like it's all connected. Yeah, so I thought about how many dimes are in 60 cents.
Because 3/5 is 60 cents and 1/10. I gotta have to say it out loud. And 1/10 is 10 cents. So it's like you said, 60 cents divided by 10 cents. How many 10 cents are in 60 cents? So you said the answer is 6. Cool. Okay. Yeah. I have no problem with that. Okay. If I just realized I totally leaned away from my microphone. Sorry about that. If I was working with kids and I saw someone with that strategy, I'm circulating around, I'm listening and stuff. Or even if a kid, well, let's say I'm circulating around and I saw that strategy, I might say to that kid, I might give him a fist bump and go, nice thinking. Hey, can you think about it in terms of fractions and the candy bar I have on the board?
Yeah.
I'm gonna say like, nice thinking. Can you also think about it in terms of like the candy bar I have on the board?
Yep.
So Kim, I'm a little curious. Can you think about it in terms, especially like the problem before? So I know you guys, a lot of listeners are probably listening. So the problem before was, how many 1/5 are in 3/5?
Yeah.
How would you say that quotitively for the problem we just said? How would you say the problem we just did quotitively?
So when it was 3/5 divided by 1/5, then there were 3 1/5. Now I have smaller pieces. The pieces are half as big. And because
you have 1/10.
Yeah, 1/10. They're half as big as a fifth. And so I'm going to have twice as many pieces.
And so you're still getting 6 dimes and 60 cents, but you're also getting 6. I'm going to try to let you finish that sentence. You're also getting 6.
I zoned out.
That's okay. All right. So you're getting 6 dimes. It's okay. Yes. It's a real thing. You're getting 6 dimes in 60 cents. Now I'm looking at the fractions. And if I was pointing to the board, you'd see what I was pointing at.
6/10 in 3/5.
6/10 in 3/5. Yeah. Cool. And you kind of compared that to the problem before. So if we have 3 1/5 in 3/5, now you have smaller pieces. You've cut the pieces in half. You'd have twice as many pieces, right? What if you just were thinking at this problem, if I literally just said for cold 1/10, how many 1/10s are in 3/5? I'm just curious if there's any other thinking that comes to mind. And I'm pointing, you can't see, I'm pointing at the picture that I had on the board when we were talking about how many, I'm interrupting your thinking. Sorry, Kim.
No,
Do
go
you,
ahead.
you want me to tell you
No,
where I'm
okay.
pointing? Okay, I'm going to tell
Yeah.
you where I'm pointing. So on the board, when we did 3/5 divided by 1/5, I drew a whole candy bar. I cut it into fifths, and I circled 3 of the 1/5s. And I said,
Okay.
how many 1/5s are in 3/5s? Now I'm still looking at a candy bar that's cut into fifths, and I've circled 3 of the 1/5s. And now I'm asking how many tenths are in 3/5s.
So when within each one of those fifths, there's 2/10. Is that what you're asking?
Mm-hmm. So if
I don't
there's,
think I understand your question.
yeah, so where you just said, so in each of those fifths, I've circled 3/5,
Mm-hmm.
right? And the question is, how many tenths are in 3/5? And you just said, well, in each of those tenths, there's 2/5. So you've kind of got 2/5, 2/5,
Yep,
2/5.
the other
Oh,
way around.
that's,
In each of those fifths, there's 2/10.
I
Yes.
said it backwards. You're right. In each of those fifths is 2/10.
Uh-huh.
So you've got 2/10, 2/10, 2/10. So you've got
Right.
six of those 1/10 in 3/5. So I
Yes.
would
Yes.
just kind of sort of looking at the
Oh, the
picture,
model. Yeah.
the model where I kind of had 2/10 in each of those fifths. And so I
Yes.
could sort of like, well, if there's 2/10 in 1/5 and I've got 3 of those fifths, then I
Mm-hmm.
3 times those 2 would be 6.
2/10. Mm-hmm.
Yeah, I wish I was pointing. It's so much better pointing. Woo! Maybe Kim, we should do a video podcast one day and we can
Oh my
actually be
goodness.
pointing at stuff. I don't know. Y'all,
Can you imagine?
we thought about doing a video podcast, and every time we do, it's me that's the holdout because I'm like, I'd have to like brush my hair and
Stop it. That's
like,
true.
I mean, right now, what am I wearing? I'm wearing jeans and a hoodie and my
It's
glasses. Like,
real.
I mean,
It's so real.
I did brush my hair this morning, but I didn't do anything else to it.
We
Anyway,
would
okay,
just
so
laugh at each other the whole time. It's probably
well,
good we can't see each
you know,
other.
the other reason we've pushed back on doing a video podcast, we would laugh at each other all the time, but is we worry that well, like right now, I'm really cognizant that I'm talking to people who are just listening. And
Yes.
if we could point, we would probably say less because we
Yes.
would be able to
Agreed.
point, and then anybody
Agreed.
listening. So, hey, podcast listeners, we'd be super interested to know, would it be worth it? Would you be like, oh, really do a video one because we'd understand so much better? Or you're like, no, really, I'm listening in my car and I would not be
Yeah.
looking. So yeah, I'd be super curious. All right. Our last problem was how many tenths are in 3/5 or 3/5 divided by
Yep.
1/10.
Yep.
The next problem is 1 and 3/5 divided by 1/10. 1 and 3/5 divided by 1/10. What are you thinking about?
$1.60.
All right, how many
All right,
dimes? Well, go ahead.
yeah.
How many dimes
How
are in
many how many
$1.60?
dimes are in $1.60?
Yeah, how many?
So 16. But also, I've been writing down the problems.
Uh-huh.
I have not been drawing a model, but I've been writing down the problems. And you asked me 1 divided by 1/10,
Mm-hmm.
and you asked me 3/5 divided by 1/10.
Uh-huh.
So when it was 1 divided by 1/10, it was 10, and 3/5 divided by 1/10 was 6. So if you put those together, 1 and 3/5 divided by a tenth would be the same 16.
Would be that 6 plus or 10 plus the 6 is 16.
Yeah.
Yeah, nice.
Yep.
I love that reasoning. Super. And if I'm doing this problem string with students, those things are on the board. So the students have access to those. I wonder then if I might grab that problem, 1 divided by 1/10, and that model that we used to see that 1/10 in that whole candy bar. And then I might also grab the model where I had the 3/5 divided by 1/10 and grab that piece of it and show those 6 1/10. And I've got the 10 1/10 and the 6 1/10 would be the 16 1/10. Nice. Next question. How about if I asked you 1 divided by 1/3?
That'd be 3. 3 1/3 and then 1 whole.
Cool, because we just got a whole, and you're asking how many 1/3 are in 1. It's just 3. I don't know why I repeat what you say every time, but it helps me think about what it literally helps me think about what you just said.
Yeah.
So I know sometimes listeners, you might be like, why does she repeat what Kim says? Well, it's because I have to think about what Kim said, and it helps me think about it. Okay, so you said that was 3.
Yeah.
Now I'm going to ask you 2/3 divided by 1/3. 2/3 divided by 1/3.
2.
And how do you know?
I feel like we're going somewhere fun. Excited.
Okay.
2 1/3 is 2/3.
So if are you thinking quotitively, you're saying how many 1/3 are in 2/3, and you're like, there's 2 of those. There's 2 1, and it's we mentioned earlier that we could say 2/3 as 2 1/3.
Yeah.
So when I say that problem like that, 2 1/3 divided by 1/3, you could be like, well, how many 1/3 are in 2 1/3? Two.
Yeah.
All right, so 2/3 divided by 1/3 is 2. Cool. Next question. How
Yep.
about 2/3 divided by 1/6? 2/3 divided by 1/6.
That's going to be 4.
Because
Because just like we were talking about with the fifths and the tenths, when you asked me about how many thirds are in 2/3, then that was 2. But now the size of the piece is half as big. So there's going to be twice as many pieces.
cool. I love that relationship.
Yeah.
That's a little bit more sophisticated than maybe I might ask a kid to describe first. I might
Right.
have a kid say, "Well, I know there's 2/6 in every 1/3.
Yeah.
So if there's 2 1/3, I can sort of picture those that 1/3 and that 1/3. I know there's 2 of them in 2/3. In each of those third, there's 2/6. And so, yeah,
Yeah.
kind of like you're twice as many, but I might be looking a little more additively at first.
Hmm.
There was a reason I mentioned that is I want to make sure people are understanding. Yes, I want kids thinking multiplicatively about these, and that's what Kim just did. Well, if the pieces are half as big, then there's going to be twice as many. But I also can allow kids to enter as they're sort of thinking about it additively. I want to help kids enter thinking about it additively, and then also help them transition to thinking about it more multiplicatively. All right, what is 2/3 divided by 1/12?
8.
And how do you know?
When it was 2/3 divided by 1/6, that was 4. So now again, the pieces are half as big. So there's going to be twice as many, which is 8.
So
But
if
also
there's
I could go
Oh, go
ahead.
ahead. Well, let me just repeat that a slightly different way.
Yeah.
So if I'm asking how many 1/6 are in 2/3, and you're saying there's 4, and then I ask how many there is of something half as big in 2/3, how many 1/12ths are in 2/3, then you're like, there's got to be twice as many, there's got to be 8. Okay. Okay. And where else were you going to go?
You had asked me earlier 2/3 divided by 1/3.
Mm-hmm.
So I'm thinking that I know the relationship between 1/12 and 1/3, and it's going to be it's a fourth as big. So we just
Mm-hmm.
did the half and double relationship,
Mm-hmm.
but there's also a quadrupling quartering relationship to the previous problem, 2/3 divided by 1/3.
So if
So
a 12th, oh, keep going.
if a 12th is 1/4 as big as a third, then I'm going to need 4 times as many pieces.
So instead of getting 2 1/3s in 2/3, you're going to have
Yeah.
8 1/12ths in 2/3. Nice. And I didn't talk about the modeling here, but I would also be making sure that I have a whole candy bar. And when we talked about thirds, I would have like sketched out the 2/3 of the candy bar. So I've got the whole candy bar. I've sort of circled the 2/3 because that's the whole that we're dealing with. That's the unit we're dealing with every time. And then
Mhm.
the first question I asked how many 1/3s were in there, and you were like 2. And then I asked how many 1/6ths were in there. We would have cut each of the thirds in half to show those 1/6. And you're like, there's the 4. And then I
Mhm.
would have said, like, where are 12ths? Like, how are you thinking about 12ths? How would you even cut a candy bar into 12ths? And we would have talked about how 12ths were half as big as the sixths, like you said, but they're also a fourth of the thirds, and there's that quadruple relationship.
I have a
Nice.
question.
Yeah.
I don't want to derail this because I'm afraid we'll go a little too long, but I wonder what you think about this.
Okay.
Sometimes I think that when we have numbers like 2/3 and 1/12,
Hmm.
sometimes that can be maybe a little bit overwhelming or a little bit like, oh my gosh, I don't really know kind of situation for kids
Hmm.
until they have a lot more experience, or at least some more experience. But I wonder what you think about going back to the unit fraction of, instead of 2/3, saying, okay, do you know how many twelfths are in 1/3? And then once you know that, like getting back to the unit fraction stuff, and then
Uh-huh.
going, okay, but now we don't need 1/3 divided by 12. We need 2/3 divided by 12. Do you ever do problem strings that
Let's do
scale
one
up?
next week. Let's do one
Yeah.
next
Okay.
week that
Okay.
could
Okay.
get
Okay.
at that relationship. Maybe we'll
Okay.
see. We'll see what
All
happens
right.
next week. But
Okay.
absolutely, we would
Okay.
absolutely want to develop the relationship that if we can think about how many 1/12ths are in 1/3, then
Yeah.
how can that help us think about how many 1/12ths are in 2/3?
Yeah.
And let's like actually answer that question. So how many 1/12ths are in 1/3?
4.
How do you know?
I'm trying to think of how I know. Because if
Yeah.
you have a third, you would have to cut it. Half would be a sixth, then a fourth would be a 12th.
Yeah, and as you said that, I drew a candy bar and I cut it into
Uh-huh.
three pieces. I'm like,
Uh-huh.
because you said, well, if you have a third, so I drew a candy bar
Uh-huh.
and cut it into 3 pieces. You
Uh-huh.
said, well, if I cut that third in half, I'd have sixths, right?
Yeah. Yep.
And you're like, okay, so there's the sixth, and then you said, but then I'd have to cut those in half to get 12ths, and I've only really cut that 1/3. I've just that 1/3. I cut it into 2/6, and I cut each of those sixths into 2/12ths. So in that third, I now see 4/12ths. So that 1/3 has 4/12ths in it, right?
Mm-hmm. Mm-hmm.
Yeah,
But we don't need 1/3. We need 2/3.
because the
So it'd be
problem is
twice as
2/3
much.
divided by 1/12th, right? So we don't just have in one. It's a 1/3 divided by 1/12th is 4. So 2/3, twice as much, divided by 1/3 is twice as much, 8. Nice. Well, I almost wonder if your problem was a better. Well, is that your problem, or is it just a different way of thinking about? Yeah. Anyway,
A different way of thinking. Yeah.
a different way of thinking about that last problem. I'm going to give you one last problem for this string.
Okay.
Okay, so I'm just going to note the recent problem we did was 2/3 divided by 1/12, and you got 8.
Uh-huh.
Now I'm going to ask you 1 2/3 divided by 1/12. In other words, how many 1/12ths are in
Yeah.
1 2/3?
So we just did 2/3 divided by 12th, a couple of different ways, and talked about how that was 8.
Mm-hmm.
And so then I'm gonna also think about the extra 1, the leftover 1,
Mm-hmm.
divided by 1/12 is 12. So if 2/3 divided by 1/12 is 8, and 1 divided by 1/12 is 12, then 8 and 12 is 20. 20 twelfths.
There are 21/12ths in
Yep.
1 2/3.
Yeah.
Super thinking. And there's a few different ways that we could think about that, but I think at this point, I think we've done some nice fraction reasoning, fraction division reasoning. Teachers, I wonder if any of you, or listeners, I wonder if any of you are thinking, whoa, I mean, that's a lot of thinking. Like, I got kids that don't even know their multiplication facts, and you want us to be, I hear you. I hear you. I acknowledge that the thinking that we just did was not trivial. Like, we were thinking, but in a big way, we were almost thinking less about fraction division, and we were thinking about the definition of unit fractions. Like, as we're asking ourselves, how many 1/6 are in 2/3? 2/3 divided by 1/6. If we're thinking about it quotitively, how many 1/6 are in 2/3? We're asking ourselves, what's the relationship between 1/6 and 1/3? And so then, therefore, what's the relationship between 1/6 and 2/3? Like, what we're really helping students think about fractions, the definition of fractions. What does it mean? What is the relationship between 1/12 and 1/6, and 1/12 and 1/3, and 1/12 and 2/3? The quotative meaning of division can be super helpful to helping kids actually reason about what fractions mean. And we need that. In other words, you might be like, Pam, in my section for fraction division, I got a day. I got a day to say ours is not the reason why, just invert and multiply. I don't have all this time to help kids reason about this. Well, then we'll get what we've gotten, and which is kids not reasoning about fractions, kids just memorizing a bunch of rules and then mixing and matching the rules and getting it all screwed up, and we get the mess we've had. What we need is kids to actually understand the meaning of fractions. So I'm actually suggesting we could ask some of these questions that we asked today and in last week's, and what we'll ask next week. We could ask some of these questions in grade 3. Like, as kids are thinking about the meaning of 1/3, I could ask the question 1 divided by 1/3. Now, I probably wouldn't write it that way. I would say things like, hey, how many 1/3s are in 1? And third graders should say, 3, right? And then maybe I'll write it as 1 divided by 1/3, but I want to like have them think so that I might say, well, how many 1/3s are in 2/3? Now, you might be like, Pam, that's a 5th grade standard. That's fraction division. Or is it? Like, of course it is, but there are the meaning of fractions we can get at. We can help develop these relationships by asking questions like we did today in a quotative kind of way. How many of the divisors are in the dividend, to really help students reason about the relationships of fractions. And then maybe we can develop everyone to think more and more like Kim, like mathematicians, like
Yeah.
really reasoning about fractions. Anything else you want to
Very
say
cool.
about that?
I don't think so.
Like, I'm going to push you a little bit on this, Kim. I'm wondering if you could tell me, as we were doing this problem string, how much division were you thinking about, and how much like relationships between fractions were you thinking about? Do you know what I mean?
You know what? Last week I think you mentioned that working with some of the strategies with whole numbers can be really useful. And I found myself thinking about that a little bit, that I
Mm-hmm.
know some relationships that now I'm just being asked to use those relationships with unit fractions.
Nice.
So I'm drawing back on things that I know and have had experience with whole numbers.
Mm-hmm.
So if we have an opportunity to do that as well with students, then it doesn't feel quite so big a hurdle.
So overwhelming here.
Yes. Yes.
Yeah, absolutely. That's an example, I would say, of kind of the finger thing that we've done
Yeah.
before, where students can be kind of all over the map. And if we do a problem string like this, they should be able to access it kind of where they are. For example,
Yes.
I just talked about how a third grader could think about several of these problems just by using the definition of fractions, while
Right.
Kim is simultaneously using these really nice multiplicative relationships in
Right.
division that
Right.
she's already developed from whole number division.
Yeah.
That's a great example of, if we mathematize with students, students can enter where they are, they all learn and grow, and we all think more and more like mathematicians. Nice. All right. So, y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.